A question problem as shown in this figure. First mass given 5 kg. There is a friction, so coefficient of friction also given 0.4, angle 30°. Question was what should be a value for second mass in order to keep this system at rest. So here, before writing this writing equations, we should be able to analyze, we should focus on the problem. It can be at rest for some certain values, so there will be a range like between 1 kg and the 3 kg, like between 2 kg and the 5 kg. How we can find the minimum value and the maximum value? This is the question. So minimum value for M2 is when the system will start its motion in this direction, or let's say M2 will start moving upward. So at what minimum value second object will go upward, and this will be minimum value. Maximum value we can find when it will start moving downward, second object. So here we have two questions basically. From one question we are shifting to the two questions. So we need to find two values. Minimum value when it will just start its motion upward, second object. The second version, the maximum value for second mass when it will start its motion downward, let's say. So let's start with the minimum value. We need to find minimum value for M2. It means it will start its motion upward. It means friction force for the first object will be directed to the upward friction force, because it wants to move downward. And in this direction we have m1g sine alpha, as you know, the component of its own weight, and we have m1g cosine alpha and normal force n1. As you know, normal force equal to m1g cosine alpha in this case. And of course we have a tension also here. So as you see, according to the Newton's second law, m1g sine alpha should be greater or at least equal to tension plus friction force. It should be equal or greater in order to move downward. So we are assuming that acceleration equal to 0. It will move in this direction if we have this condition. This condition should be applied. So of course we will say that it's equal, to make it simple, mg sine alpha equal to tension plus friction force. This is basically Newton's second law with zero acceleration. What about friction force? We assume that friction force reached its maximum value, because it will move. Just small hint, small touch, it will move downward. So it means we will assume that it reached its maximum value. As you know, mu times normal force, and normal force equal to m1g cosine alpha. Now let's come to the second object. We have the same tension upward, its own weight downward, and tension should be equal or greater than weight. Only in this case it will go upward. So we will assume that tension equal to m2g, and we can substitute it here. From here we can find m2. So let me copy the first equation again. m1g sine alpha equal to tension, which is m2g, plus mu m1g cosine alpha. We can remove gravities, and from here m2 equal to m1 sine alpha minus mu m1 cosine alpha. or we can take m1 outside of the parenthesis, so we have sine alpha minus mu cosine alpha. So answer will be m1 is 5 kilogram sine 30 minus 0.4 times cosine 30. From here, answer will be, let me use my calculator, 5 times sine 30 minus 0.4 times cosine 30. So answer is 0.76, yes? 0.76 kilograms approximately. So if we have this mass is enough to keep it at rest, basically. If you have a smaller mass, let's say 0.75, then it will move upward. Now, second part, what maximum kilogram we can use to keep it at rest. So let me create new page. Let me draw it quickly. Free body diagram. Now, the difference between the previous case and this one, M2 wants to move downward. So we are trying to find maximum mass. Maximum M2. It means if you have a mass more than this maximum value, which is unknown for now, it will go downward. Second object will go downward. So here we have a tension. Here we have a M1G sine alpha. The difference is direction of the friction force. Here, direction of the friction force will be directed downward because it wants to move upward. So again, we have M1G cosine alpha and the normal force. Here we have a tension and a weight. So as you know, M2G should be greater than tension for the second object in order to move downward. So we will assume that M2 equal to tension, at least. Now let's come to the first object, M1. Tension should be greater or equal M1G sinus alpha plus friction force. Tension should be greater in order to move upward for the first object. So tension equal to, we will use equal sign for now just to find maximum value. M1G sine alpha plus here again friction force reached its maximum value, mu M1G cosine alpha. So these two equations are equal to each other, as you see, tension. So M2G equal to M1G sine alpha plus G cosine alpha. You can remove gravities, and the final answer equal to M2 equal to M1 sine alpha plus mu cosine alpha. So 5 kilogram sine 30 plus 0.4 times cosine 30, and the numerical value, one second, let me use my calculator. Sine 30 plus 0.4 times cosine 30 times 5, answer is 4.23 kilogram. So we calculated minimum value, which is 0.76, I think, yes, and the maximum value 4.23. So answer for this question is any mass between these two values, 23. So any mass between these two values, 0.76 and 4.23, this system will be at rest. So answer is between these two values. Equal, yes, actually. Equal, yes. So question was, which object will move faster? So in order to compare their velocities, of course, we need to find their accelerations, then we can compare. So let's start with the first figure. We have a force as shown in this figure. Let's rewrite it in terms of components, horizontal and the vertical components. So I will remove it. Its x component, horizontal component, will be equal to f times cosine alpha. Vertical component will be equal to f times sine alpha. And we have a normal force, let's call it N1. We have a weight M1G, let's call it. And we can call it just M1. Yes, in both cases masses are equal. Here, yes, N1. And the friction force to the left equal to F1, let's call it. So as you see from this figure, vertical component, let's pay attention to the forces in vertical component. So N1 plus force times sine alpha equal to mg. From here, normal force equal to mg minus force times sine alpha. So which is mass equal to 8, 80 minus force equal to 100, sine 30, 0.5 sine 30. So normal force will be equal to 30 newtons, as you see. So friction force equal to coefficient times normal force. So 0.2 times 30. So friction force in this case equal to 6 newtons. And we know that this object can move in horizontal direction. It will move in horizontal direction. So resultant force in horizontal direction equal to F times cosine alpha minus F1 equal to M. Let's call it A1, acceleration in this case. So 100 times cosine 30, which is 0.86 approximately. 866 minus friction force 6 equal to mass 8 times A1. So from here acceleration will be equal to 10.07 approximately. 0.7 meter per second squared. This is acceleration of the first object in first case. Let's do the same calculations in the same way for the second object. Let me write the force in terms of components. So horizontal we have F cosine alpha. Vertical downward, here you should be careful, F times sine alpha. And the downward we have weight. Upward we have a normal force, let's call it N2. And the friction force to the left, let's call it F2. So normal force, let's pay attention to the forces in vertical directions. So weight directed downward and the F sine alpha also downward. Upward we have a N2. So from here we can find reaction force. Weight is 80, force is vertical force is 50, 100 times sine 30. So normal force in this case will be 130 newtons. And it can move in horizontal direction. So force times cosine alpha minus friction force can be equal to MA2. 100 times cosine 30, 0.866 minus friction force, it maximum, of course, it can be equal to 130 maximum. We are assuming that it will move. So equal to 8 times acceleration. So as you see, 86.6 minus 130. So our force in horizontal direction is less than the maximum value for the friction force. What does it mean? It means it will not move. It means it will not move. Yes? Sorry, there is a mistake, because friction force it's not equal to 130. We didn't calculate friction force. This was my mistake. Friction force is unknown. First, let's calculate friction force. You know, friction force equal to coefficient times normal force. Sorry, guys. Friction for coefficient 0.2, normal force 130. So friction force equal to 26. Yes, it's not 130. 130 is just normal force. Friction force equal to 26 maximum value. Now it's okay. So 86.6 minus 26 equal to 8 times acceleration. And from here acceleration equal to 7.5, approximately 7.5 meter per second square. So as you see, A1 is greater than A2, so in the first case object will move faster.